Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about Venn diagrams and conditional probability. Now, in these particular type of questions we're going to tackle here, it's going to be a combination of using Venn diagrams or our conditional probability formulae. So you need to know everything we've done up to this date, and it's going to be a mixture, and you're going to have all of those things in your mind to be able to solve these problems. Here are the things I need you really good at. Do you remember what mutually exclusive means? Well, hopefully you would have realized it's the probability of A intersection B is equal to 0. Do you remember what independent means? Well, the key result for us is the probability of A intersection B is just the probability of A multiplied by the probability of B. You also need to have these two formulae close at hand. The probability of A or B is probability of A plus probability of B subtract probability of A intersection B and its rearrangement, where probability A intersection B is the subject. So you need to know that. And you need to know your conditional probability formulae, which are here. Pause the video and have a go at the following. So in this problem we're given various information about probabilities. What I always like to do is try as best you can to populate the Venn diagram, then think about what formulae you know, and between a combination of the two you will always be able to solve these type of questions. So let's get on and see if we can start by populating a Venn diagram with A and B in it, assuming A and B have an intersection. Now we're told the probability of A intersection not B is 0.15. That means that everything that's not in B but is in A. So we can certainly put 0.15 here in this section. We're also told the probability of B is 0.35. Now we shouldn't put that in the Venn diagram. We should only put in every single section. We shouldn't put a whole set like this. We should just put the different regions. But that yellow, which I'm going to highlight here, that yellow 0.35 is what that represents there. And lastly, probability of A given B is 0.1. We can't necessarily put that on the Venn diagram yet. Now we're asked to start with what's the probability of A or B. Do we use the probability A or B formula? Well, it was not going to help us in this case because we don't know the probability of A intersection B, but by common sense and by populating our Venn diagram we can see it must be this 0.15 added to the yellow region, which we said was 0.35. So we can state that this must be equal to 0.15, this add 0.35, which if we add those together we get 0.5, and we're done. So that bit of common sense there allowed us to work this out without using any formulae. Now we have to work out the probability of A and B. Can we do that? Well, we know two formulae for probability of A and B, and I'm going to write them down. We know the probability of A and B is the probability of A add the probability of B subtract the probability of A or B. That's a fact. And we also know from conditional formulae that the probability of A and B is going to be equal to the probability of B multiplied by the probability of A given B. Now, which one is useful to us? The first one isn't, because we don't actually know the probability of A yet. We don't know that. We just know the probability of A not B, and we also don't know the probability of A intersection B, which we're trying to find out. So this one's not going to be useful, but this one is, because we do know the probability of B, it's given, and we do know the probability of A given B, it's given up here. So we can just state that we're going to say this is the probability of B multiplied by the probability of A given B, which is equal to 0.35 multiplied by 0.1, which is 0.035. Now let's put that in the diagram. Let's put that in here, 0.035. Lastly, we're asked the probability of A. Well, we can see that from the picture, because the probability of A must be this probability 0.15 add 0.035. So using the picture there, that is what helped us. And we get ourselves, when we do that, 0.185. So you can see in these type of questions, it's a combination of thinking clearly using the Venn diagram and a combination of thinking what formulae we can use. Let's try another one. Pause the video and have a go here. So again, we're given a scenario. The trick is to try your best to populate the Venn diagram and also think about what formulae you know. Now in this case, is there anything we could put in the Venn diagram? We can't put this probability, the given one, or this one, or the probability of B, because the probability of B is this whole thing here. We shouldn't populate the Venn diagram with a whole set. We should only put regions. So there's nothing really we can put in as yet. So let's go and think about formulae instead. The probability of A intersection B. Well, there's two formulas we know for that, involving a union, which we have no information about. So let's use the conditional probability formula we know. We should know that this is the probability of B multiplied by the probability of A given B. And we've got those two pieces of information here and here. So we just multiply 0.3 by 0.1 and we have our answer 0.03. And we can put that in to our Venn diagram as we go along. Then it says, what's the probability of A intersection not B? Well, we don't have any information about the probability of A, so we can't really work that out with the Venn diagram. Let's think about our conditional probability formula as well. The probability of A intersection not B, we can state that is like the probability of not B multiplied by the probability of A given not B. Now, the reason they were useful is I've got the probability of A given not B, and I can easily work out the probability of not B. It's simply 1 subtract the probability of B, which would be 0.7. So I've got everything I need here. It's 0.7 multiplied by 0.6, and I'd get 0.42, and I'm done. So the probability of A intersection not B, everything in A that's not in B, I can put here as 0.42. Now, what's the probability of A? Well, this is where the Venn diagram comes in really useful. It's clearly the 0.42, add the 0.03, so it's 0.45. So therefore, the combination of those formulae and the Venn diagram came into super use there. Okay, next one, probability of B given A. Well, the easiest way probably to do this is just to use the conditional probability formula. That's the probability of A and B divided by the probability of A, because we have all that information now. So it's going to be 0.03 divided by 0.45, and if you were to do that in your calculator, you get yourself 1/15th, or as a decimal it is 0.06 recurring. Last one, again let's just use the formula, the probability of A not A intersecting with B divided by the probability of not A. Well, currently we don't have the information for the probability of not A intersect B, but we could work it out. We know for sure the probability of B is 0.3. We know that this little portion is 0.03, so if we do 0.3 subtract 0.03, this gives us that this region here must be 0.27. So this would be 0.27 divided by the probability of not A. Well, given the probability of A is 0.45, not A must be 1 subtract 0.45, i.e. 0.55. And if we do that in our calculator, we get ourselves 27/55, and if you were to put it as a decimal, it would be equal to 0.490, and the 90 repeats like that. It's better in the case of decimals that don't terminate to leave your answer as fractions in this case and in this case. Okay, next question. Pause the video, have a go. Right, let's see what we can put into the Venn diagram. Can we put the probability of B? Well, we can't put a whole thing in there. We can't put this one, and we can't put this one. Maybe we're best thinking of our formulae. Okay, the two we know that the probability of A and B is the probability of A, add the probability of B, subtract the probability of A or B. And we also know that the probability of A and B is the probability of B multiplied by the probability of A given B. Now, which of these is useful to us? The top one currently isn't, because we don't have the probability of A, but this one is here because we've got the probability of B and the probability of A given B. So we just simply do a half multiplied by 2/5, and we get ourselves a fifth. Okay, next one we're asked the probability of A. Well, we do know that the probability of A or B is equal to the probability of A plus the probability of B, subtract the probability of A intersection B, and that's useful to us in this case because we have been given this one here, we have been given this one here, and we have just worked out the probability of A and B here. So we could use that to find the probability of A. Rearranging that, the probability of A must be equal to the probability of A or B, subtract the probability of B, add the probability of A intersection B. So we're going to say it's 13 out of 20, take away a half, add 1 out of 5. And if you were to do that, you get the following answer, 7 out of 20, and you're done. Okay, next one, probability of B given A. Well, that's the probability of A and B divided by the probability of A. So we've got that from part 1, that's going to be a fifth divided by what we've just worked out, 7/20. And if we work that out, that's a fifth multiplied by 20 over 7, and that gives us 4/7 if we work that out. The last one, the probability of not A intersection B, well, that is basically this region here. Is there any way we can work that out without a formula? Well, we do know the probability of B is a half, the whole thing's a half, and if we subtract the fifth here, we would get ourselves what's left over. And if we do that, we get ourselves 3/10. So that we can just get from the Venn diagram, is 3/10, and we're done. And that's it for this particular video. Thanks for watching.